In the last two videos, we've created many of the systems that we need in order to create our Tetris game. We have this grid list that represents all of the information about all of the tiles that have been saved onto the Tetris grid. And as you can see, that information, like these items, these tiles at list item 3, get rendered onto the board. We also have this falling piece that we can manipulate using these 4 variables. And what we want to do in this video is sort of tie these two things together and allow the player to have a bit of control. So this is where we really start making it be more of a game rather than just sort of a system. So the first thing that we want to do is make this falling piece be controllable. And I think what it makes sense to do is start by generating a random piece and putting it right at the top of the screen. So I'm going to make a block for that, and we'll just call it generate new piece. Now, Tetris has a bit of a special way that it randomly selects falling pieces. We're just going to generate a new piece right at the beginning. It uses what's called a random bag, so that it's not just selecting pieces totally at random. You'll never go more than 7 in a row without getting the same piece twice. But for now, we're going to keep it a little simpler than that. Later on in a future video, we'll go back and make it so that this piece type is randomly selected, but it's doing it using the proper Tetris system with the random bag. But for now, we're just going to say pick a random piece type from 1 to 7, and that'll work okay. So it's going to pick a random piece type. You can see I'm clicking this block and getting 7 a lot. That's how randomness works. Sometimes strange things happen. But we're picking a random piece type. And the other thing that we want to do when we generate a new piece is sort of move it back to the top of the screen. So we're going to set the piece Y to be 1. So that the very top of the piece is right at the top of the screen. And remember that there are 2 invisible rows. And so row number 1 is actually not this top one, not above it, but even one farther above it. But then some of the pieces sort of extend back down. So it'll feel about right. And I think this is, as far as I can tell, this is how Tetris, the actual game, does it as well. Then we want to set the piece X. And the piece should essentially be centered on the screen. The rule is that it's going to be centered if it's possible. So if you have an even number of an even width for your piece, then it's just going to go right in the center. Otherwise, it's going to go one left of center if it's an odd width, like this 3. It actually happens to be in the right spot right now. So we can see that a piece X of 4 is generally what we want. With most pieces that are 3 wide, a piece X of 4 is perfect. So you can see if I change this piece type, that's good. That's good, that's good, that's good, that's good, and that's good. The problem is piece type number 2 here, which can be centered because it's even, but if we start at 4, that's actually wrong. For piece type 2, we want to start at an X of 5. So we'll just add a simple little if statement in here to say normally set it to 4, but if the piece type is going to be equal to 2, if you're piece type number 2, then what we want to do is set the piece X to be 5. So if the piece type is equal to 2, then set the X to be 5 rather than 4. So there we've got that. We can generate some random pieces. The last thing that we need to do is set the rotation. And the rotation is actually not randomized, as far as I can tell. I think that the piece rotation always starts at 0. So this should generate a new piece for us. Every time it'll generate a random top piece, and you can see it up there doing exactly what we want. Now it is rendering off the screen, you might notice. That's okay for now. We'll go back and fix that later. So what we want to do now is make the piece fall. So I'm going to create an update piece. Maybe we'll call it update falling piece block. Update falling piece. And for now, this will just make it fall. It'll make it go down a grid space. And in the future, this will do more than that. It'll also take care of sort of user input. If you press the right or left buttons or rotate the piece, this will do all of that. So when we want to update the falling piece, we want to make it go down by 1. So we can just say change piece Y by 1. And this will work. You can see it does fall. The problem, of course, is that it falls off the bottom of the screen. And what we want instead is that when it gets to the bottom of the screen, it should sort of lock into place, add itself to this grid list, save itself to sort of the permanent grid, and then generate a new falling piece. So the first thing that we want to do is be able to identify whether we've hit the bottom of the screen. And this is actually tricky because there are a lot of different rotations and a lot of different sort of ways that the piece can be. And so it's not as simple as just checking, is your y greater than 20, for example. That won't quite always work. So what we want to do is actually use our get piece coordinates block. And so we are going to get the coordinates of the falling piece. So we're going to say the piece x, the piece y, the piece rotation, and the piece type. But what we want to do is not check where we are now. We want to check where we will be if we were to hypothetically move the block down by 1. And the great thing about this custom block is that we can totally do that. We can plug in piece y plus 1, and even though our actual piece y variable hasn't changed yet, we can check what would this piece's coordinates look like if we did. If we did increase the piece y by 1, where would this piece be? And then what we can do is, remember that this custom block that gets the piece coordinates, it will affect both our piece tiles x and piece tiles y. It'll give us sort of 4 different coordinates for the 4 tiles that make up our piece. And what we can do is we can say, if the piece y, so what we want to do is we actually want to loop through all of these. And we want to say, if for each one, the y coordinate of the tile, I'm just checking number 1 for now, we'll go through and check all of them. If the y is greater than 22, that means that this particular tile is off the bottom of the screen. And so we want to sort of do this check, but we want to do it for all of the tiles. And if any of them are off the bottom, that means that we can't move this piece down anymore. So in order to sort of loop through and check all of the different tiles, we're going to use an n variable. And this n, remember, is just sort of a generic counter. We could call it anything we want, and we're just reusing it here from a previous setup. So we're going to repeat for, whoops, I bumped the microphone. I don't know if you heard that. And we're just going to loop n so that it starts at 1 and then goes 2, 3, and 4. And for each of those times, for each of those values of n, we're going to do this check, where we say if item number n of the piece tiles y is greater than 22, so if the tile that we're currently checking is below the bottom of the screen, then we want to do something. We want to say, this is bad, we have sort of an invalid piece. So in order to do that, I'm going to make a variable called isValid. I'll throw a question mark at the end, just to sort of show that this is like a true-false type of thing. So we'll say isValid, and by default, we'll assume, yeah, true. The piece probably is valid, that if we move it down 1, it'll be okay. But then we're going to check, and if any of the individual tiles that make up this piece are off the bottom, we'll say that the piece is not valid. We'll make that be false. So when we do this, if I sort of run this code, imagine that we have our piece, let's see, if our piece is rotated maybe, I'm going to try to drag it so it's off the bottom of the screen. That one doesn't go off the bottom, but maybe a piece type of 1 would. Yes, see, a 1 can go off the bottom. And so if we show the isValid variable, yeah, there it is. IsValid is false. But if we move up a little bit, it says now this is true. The piece is valid. As soon as we hit this one, it says false because, again, remember, we're checking sort of 1 below where the piece currently is. We're checking piece y plus 1. And so it says, hey, this piece, if you move it down any farther, is no longer going to be valid. You're going to be in trouble. And we can actually use that to help us determine when to stop the piece. So we're going to do a little if-else check that says if the piece is valid, so if our piece, or our isValid variable, if that variable is true, then it's valid, and we can move it down by 1. We checked, when we move it down by 1, will it be valid? And if it is, then okay, let's actually do the move. For real, let's commit to it and move it down. If it's not, well, we'll deal with that in a minute. So let's try this out. We've got our falling piece, And when it hits the bottom of the screen, it stops. The piece Y is no longer going up because it knows if it did that, it would be invalid. So there we go. We can try this with all the different pieces, and they all sort of work like we want to. Now what we want to do is say, all right, in this else bit, if the piece is not going to be valid, if we've hit the bottom of the screen, we want to store that piece onto the grid. We want to say take sort of all of these tiles, all of the coordinates that we found here, and store them onto this grid permanently, and then generate a new piece. So in order to do that, I'm going to make another block. We always make a lot of custom blocks around here. And we'll just say store piece to grid. And we'll create all the same inputs where we have the piece X, the piece Y, the piece rotation, and the piece type. And so when we do this, what we want to do is we want to get the piece coordinates. Anytime that we want to store a piece onto the grid, we're going to get its coordinates. And we can literally just plug all of these in because they're the exact same variables. We're going to get the coordinates, and that'll set our lists again. And when we have the lists, now we want to loop through each of these and update the grid so that it knows that there is a tile there. So I'm going to do the n counter again. We're doing the exact same thing where we use n to loop through each of the 4 tiles that make up the piece. So this counter should feel pretty familiar by now. And we're going to say for each one, we want to update the particular row of the grid so that it has this tile inserted into it. And so what we really want to do is just replace a single letter of our list. But this is actually kind of tricky because there's no block in Scratch that says, replace letter X of item Y of a particular list. That's not built in. All we can do is replace an entire item all at once. So this is going to be a bit of a challenge, isn't it? I think we're going to need another counter because we want to use n, but we also want to have another loop happening inside. And so I'm going to create a second counter that I'll call I. Again, that name is pretty much just made up. We could call it whatever. And we're going to make I go from 1 to 10. And so this loop, 1 to 10, is sort of going through for each column in a particular list item. And what we want to do is, because we can only replace an entire grid list item at once, we can only replace an entire row at a time, before we do the replacing, we're sort of going to build up exactly what list item we want in a variable. So I'm going to call it new grid row. And then we're going to, once we've created this new grid row, we will swap it in to the spot on the grid. And the particular row that we want to replace depends on the Y of the tile that we're storing. So how do we know what this new grid row is going to be? Well, we're going to start with the new row being empty. And for the most part, we're just going to copy the existing row. So if we're editing row 22 to insert a tile at maybe an X of 3, for the most part, we're just going to copy these zeros into the new grid row. So as we're doing our I loop, and I is sort of the X coordinate, the column that we're going through, we are just going to take the new grid row, and we're going to add a letter onto the end of it, which is just the same as it already was. So we're going to figure out what was this letter in the previous version of this row, and in most cases, we're just going to copy it over. So we're going to say letter I of item Y, because that's the grid item we're swapping out. Letter I of item Y is going to be the letter that used to be there, the digit that used to be there, and we're just going to slap it onto the end of the new grid row that we're generating using this join block. But there's one case where we don't want to just copy the same data over. We don't want to just copy the same character. And that's the actual X coordinate that we want to replace. So if the I variable, if the column that we're currently copying over is equal to the x coordinate that we want to change, the x coordinate of the tile that needs to be swapped out, then we don't just want to copy the same data, we want to actually change it. And in that case, we're going to make our new grid row have the new type in there, the type of tile that we're inserting in. So here this code is kind of complicated, but essentially all we're doing is saying generate the new grid row that we want, where we're mostly just copying data over, but at the particular x that we want to change, swap in the piece type into that correct location. And then once we've built up that grid row in a variable, so this would become, if we were storing a piece at an x of 3 and a y of, maybe 22, the rotation doesn't matter yet, but the type is 4, then this grid row would be 0, 0, but then because we're changing number 3, this would be a 4, and then you'd have 0, 0, 0, 0 all the way to the end. And then we just take that new generated grid row and put it in place. So really, all of this is just saying replace letter X of item Y of the grid with our new type. We're just swapping in one letter. And then we want to do that 4 times for all of the different tiles that make up our particular piece. So we're going to take this, and we're going to put it inside of our N loop. And let's see. Oh, I see. The trick here is that I've been using X and Y, but that's not actually quite right, because we want to be getting the X and Y of the particular tile. And so that's where our N variable is going to loop through all the different tiles. And then for each tile, we're going to get the X and the Y. So this looks like a very complicated script, but in reality, all it's really doing is exactly what we say. It's going to take a piece, a particular X, Y, rotation, and type, these 4 variables that sort of represent a particular falling piece, and it's going to store that piece onto the grid. So what we want to do is when the piece hits the bottom of the screen, we want to use that block. We want to say, when you've hit the bottom of the screen, store the piece. And we just plug in the piece X, piece Y, piece rotation, and piece type, and store that piece onto the grid. Then the last thing we want to do is also generate a new piece. So now, here we go. We got falling pieces, and you can see, it doesn't quite work, but you can see that as soon as the pieces land, they get stored onto the grid. Like that, it gets stored, and then we have a new falling piece. So you can see on our grid list, we've got 7, 7, 7, 7. Those are the characters that got inserted. And you can also see, this sort of gives you a little insight into how our script works. You can see this is the new row that got swapped out when we were messing with 21. All right, there we go. Now you did notice, I hope, that the pieces are falling through each other. They fall through each other and don't really interact at all. So that's the next thing we want to work on. I'm just going to hide this new grid row. There we go. And we can hide I and is valid as well. Well, we'll keep is valid. All right, so our is valid check that's saying, has our piece hit the bottom of the screen? Remember, all it cares about is whether any of our tiles are below a Y of 22. And if so, then it says the piece is invalid. The problem with this is that it's not just the bottom of the screen that you can run into. What we just saw, you can also run into other pieces. And what we need to do is be checking the grid as well. So in order to clean up this code a little bit before we make it more complicated, I'm going to make a separate block that just says check if piece is valid. And again, we're going to have X, Y, rotation, and type. And most of the code for this block we already wrote. We're just going to copy it over from here. We're going to say all of this code is really just here to check if a particular piece is valid. And so we're just going to steal most of it. And we're going to say these variables, which we were using in our script, are now going to go here and sort of get passed through the custom block. Whoops, put that in the wrong spot. All right, so this check if piece is valid, we just sort of pulled out this code from here and made it its own block. And this will be useful. We'll use it sort of in multiple occasions in the future. So that's why we want to have it as this separate block. All right, so instead of only checking whether our y is too big, we also want to check whether the tile is in a space that's currently occupied on the grid. And if that's true, then we know that our piece is not valid. So we're going to add a second if statement, and this is going to be another reason that we might set is valid to be false. It's another reason that we might say, actually, we have a problem here. So what we want to do is say, given the x and y of the piece tile, so item n of piece tiles x and item n of piece tiles y, given these coordinates of a particular tile, we want to check, is that space occupied on the grid? Is it filled in? And the way that we know if a space is occupied is if that space is not equal to 0. If it's equal to 0, then we're all good. There's nothing there. But if it's not equal to 0, then we're in trouble. So all we really need to do now is say, like, given this x and y coordinate, what is the current sort of status of that location? What is the tile at that space? And so we will just say, get item y of the grid list, because the y sort of tells us which row to check. And then, in order to get a particular x, we're just going to get a specific letter. So we're going to say get letter x of item y of grid and check. And if it's not equal to 0, that means we are in an occupied spot and our piece is not valid. So this looks like a pretty big if statement. It looks pretty confusing, but this is really just saying if a space is occupied, then we're in trouble. This piece is not valid. Now I think this won't quite work because, yeah, you can see we're jumping through pieces, and that's because they're colliding with actually these sort of test pieces that we put at the top. And so we're just going to go in and we're going to delete that test code that we put in. That was when we were testing out the rendering to see that all the different piece types would show up on the screen. All right, now, as these fall, look at that. They fit right into each other. So that's awesome. All of these sort of collide with each other, and of course we still have trouble at the top. But now we're able to check, and these pieces are able to see if there's a piece below me, I should stop falling. All right, I feel very good about this. Now, there are only a couple things left that we want to do in this video. One is we want to make the piece not fall quite as quickly, and the other thing that we want to do is make it controllable using the arrow keys. So to make it fall a little bit slower, I'm going to add sort of a countdown timer, because right now we are running our update script, our update custom block that makes it fall. We're running that every single time we go through the main forever loop. Let me scroll up here. We're running this every single time. And that's okay. We do want to update the piece every single time, but it doesn't need to fall every single time. So we're just going to add a little timer that maybe says, we'll call it piece fall timer. And we'll make it for this sprite only. In the beginning, the piece fall timer is going to be 0. And this variable is just going to count up. It's going to count the number of frames since the last time that the piece fell down a block. So we'll start it at 0, and then when we want to update our falling piece, we are going to do what? When we want to update the falling piece, we're going to say this entire script that makes it move down one, only do that if the piece fall timer is greater than maybe 15. If it's been more than 15 frames since the last time that the piece fell down. I guess we'll show this variable actually. So this will start at 0, and we want to make it count up by 1 every frame. So we'll also just say change the piece fall timer by 1 every single time. So you can see it's counting up, and the problem here is that it doesn't reset. So we also want to say when the piece falls, set the piece fall timer back to 0. That means you've done the falling. It's been 0 frames since you last fell. All right, now you can see our piece is falling much more slowly. We've got this timer counting from 0 to 15, and only when the timer hits 15 will it fall again, and then the timer resets. So there's that. We made it fall more slowly. The other thing that we want to do is arrow key controls. So I want to be able to move the piece left and right and rotate it. So let's try this. We can do something as simple as saying, all right, when a particular key is pressed, maybe when the right arrow is pressed, we want to change the piece x by 1. Change the piece x by 1. And when the left arrow is pressed, we want to change the piece x by -1. And then we'll also do rotation as well. We're going to use the up arrow and say when you press that, rotate the piece. Change the piece rotation by 1. So now I can move right, I can move left, and this is a bad example of rotation because, ooh, how did my piece type change? Something went wrong there. Oh, I think I was able to mess with this variable. All right, but as you can see, I'm able to move these pieces around, which is good. The problem is that I can actually go off the right and left sides of the screen. So I can go too far to the right and too far to the left, and then you can see they actually kind of get stuck. So there's a lot of weird stuff happening there. So what we want to do is kind of like when the piece is going down, before we move it, we want to check if that move is going to be valid. So when we press the right arrow, we're going to start by checking if that particular move is valid. And so our piece Y is going to stay the same. Our piece rotation and type are both going to stay the same. But we want to check if our piece X increases by 1, is it still going to be valid? And only if the answer is yes will we actually move it to the right. So we say only if is valid is true. Only if it's true that when we move it to the right, it'll be valid. In that case, we will move it to the right. So let me try this real quick. If I press the right arrow, aha, you can see the script is flashing. I'm pressing the right arrow, but it's not letting me go any farther to the right because it's checking and it says, no, that piece isn't valid. We'll do the same with left, where we say, I'm going to actually duplicate all of this code and just say, hey, rather than checking 1 to the right, we'll check 1 to the left. And then if it's valid, we'll move it to the left. And again, we'll do the exact same thing for rotation, where we'll say, if the piece X and the piece Y stay the same, but the rotation is increased by 1, if that's valid after we do that, then actually perform the rotation. All right, so now I can rotate, I can move right, and you can see I can't move too far right. I can move left, but I can't move too far left. And just to try rotation here, if I rotate, ooh, something strange happened there. What went on with that? I'm not sure what's going on. All right, I figured out one thing that's wrong. You notice that we have this blue piece. You remember it sort of turned into a single dot. And the same thing happened to this orange one as I was playing around. The reason that we're having problems is because our piece rotation went up to 11 here.
But it's very, very special because if you can see, the numbers all go to 11.
It's only supposed to go from 0 to 3, but because we keep increasing it by 1, we're actually able to rotate sort of too far into a rotation that doesn't exist, and our game gets pretty confused. Fortunately, there's a block that can help with this. The mod block is going to allow us to sort of loop this number back. So if you haven't used mod before, what it does is it sort of performs division, but then rather than giving you the actual division answer, it gives you the remainder. So if we do 0 mod 4, that's just 0. If we do 1 mod 4, that's just 1. 2 is just 2. 3 is just 3. But if we do 4 mod 4, it actually loops back around to 0. And then 5 goes to 1. It sort of starts counting all over again. And 0 still works, but if we do -1, it loops back around to 3. So this mod block sort of allows us to loop our count, where we say, yes, we want to add 1, but if we get to 4, it should loop back around to 0 again. And so with this mod block, we're able to just say, loop back around. And we're going to do the same thing here. Rather than changing it, we're going to set the piece rotation to be sort of this looped back around version. All right, and now if I rotate a bunch, watch the piece rotation variable, you can see it counts up to 3 and then loops back around to 0. And our game no longer gets too confused. All right, I'm feeling good about this. We have these falling pieces. You can see they lock into place, they hit each other and stop, and they add themselves to the grid, and everything seems to be working pretty well. So in the next video, we'll keep improving on this game, we'll make it better, but it's really fun to have sort of playable Tetris going on.